So this mini lecture is talking about the difference between prime and composite numbers, which are two number groups that we're going to be working with quite a bit in this unit. And a prime number is defined as any number that has exactly two factors. So a number with exactly two factors. And those factors are itself, whatever that number is, and 1. Okay. And that's in contrast to composite numbers. And composite numbers are numbers that have 3 or more factors. And if you wanted to, you could further define that to say that the composite number is going to have itself and 1 as 2 of its factors, and then it has to have at least one other factor. So first a reminder of what it means to be a factor. A factor is a piece of a multiplication problem. So another way to think of these are that if the only times table, the only multiplication fact that the number is an answer to is itself times 1, then that number is prime. So let's look at some examples, because I think that'll make this clearer. So when we think of the counting numbers that we use, 0 and 1 are not going to go on either one of these lists, because 0 has an infinite number of factors. You can multiply 0 by anything and you still get 0. 1 is also not a prime number because it has only one factor, because 1 is itself. So our first prime number is going to be 2, because the only times table that 2 answers is the times table 2 times 1. Our next prime number would be 3, for that same reason. It's 3 times 1. And then 4 is going to be our first composite number, because it has the factors 1 and 4, but it also has the factor 2, since 2 times 2 equals 4. The next number in our prime list will be 5, and then 6 is a composite number, since it is 2 times 3 as well as 6 times 1. 7 is prime, 8 composite. 9 is going to be our first odd composite number, because it has the factors 1, 9, and 3. I also want to point out at this point that 2 is going to be your only even prime number. The reason for that being every even number higher than 2 has 2 as one of its factors. So going on up here, 10 would be a composite number because it is 2 times 5 as well as 10 times 1. 11 will be prime, 12 composite, 13 prime, 14, 15, and 16 are all composite. 17 is prime, 18 composite, 19 prime. 20, 21, 22 are all composite numbers, and 23 is prime. So let's see if we're getting close to our 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we need one more. So 24 will go on the composite list with 25, 26, 27, 3 times 9, and 28. And our next prime then will be 29. That's where we're going to stop the list for our purposes, but I'm going to put dots after both of these because neither one of these lists actually ever stops. They have not yet found the largest prime number, but these will probably be enough for what we need for our class. And that's the end of prime and composite numbers.